So in the previous video, we have learned how to create assemblies and how to generate our corridor. So once the corridor is already generated, we can now compute the cut and fill of your project. So to start with, we are going to insert sample lines into your corridor. But what is sample lines? Okay, sample lines are basis of generating sections and section view of your road design. So it will be inserted perpendicular to your center line or the alignment, and in any station or specified distance between sample lines, usually in every stationing, but you can modify that. So it depends on how you want the sample line to be placed into your corridor. So what will be the distance, the desired distance that you are going to input during the creation of your sample lines. So to start, I'll click the sample line here. Then I will click my alignment. Or is that okay? Click my alignment, and then it prompts me to name my sample line. Okay, I'll leave this as it is. For the default, I will make description of my sample line. Here, on the select data source to sample, it was already input in here, EG surface and my corridor. So I'll just click OK. Then a sample line tool pops up. In this button, I'll click this drop down menu and I'll click sample more sources. Excuse me. So we have here the existing ground or surface. I'll click this one and then add my corridor, add. Okay, then click apply, then click OK. On this icon, I'll choose this drop down again, and I'll choose by range station. This is where you are going to control how long or how far your sample line extend up to the right or and left. So, and you can control the distances between your sample line. So in here, station range, sample line should start at the beginning, true, and sample line should have at the alignment end. So at the station 2 plus 430.89. Okay, left and right swath. This is the extension of your sample lines to the left and to the right. So since we have a very wide extent of our corridor, so I'll just put this left and right to be 60 by 60. Okay, sample increment. So this is what I'm telling, that the distances of the sample line is being controlled here. It depends on your choice. So I'll try 10 meters. Okay, we'll make this as true, although it was already there. We have no super elevation, so just click OK. There you go. Okay, so you see the width of your corridor is almost 100. So what's next? On your prospector tab, scroll up this one, and then we see here our corridor. Expand the node, and then this is our corridor. Right click this corridor, and then click properties. In here we can create the surface of the corridor. Okay, we'll find surfaces, the button command surfaces. So I'll click this one. Then the data type, the link. Okay, it must be specify code. So since we are referring to the corridor, it is the surface of the corridor, which is the top. So we will add this one, then click apply, then click OK. So repeat this one, properties, to set our boundaries. Okay, in the boundary, I click this one, extend R as outer boundary, the outer portion of our corridor. Okay, so click apply, and then click OK. So good. So the surface of your corridor has been created. You see, we have here contour lines of our corridor. So next is we are going to sample the corridor again. Okay, click sample line, and then click our alignment. Yeah. Then click again, sample more sources, add, click corridor, add, click corridor, add. So you see here the style, each surface is existing ground. My corridor, that's the basic, and my corridor should be the finish ground. Okay, let's change that, finish ground. Click OK, click apply, and then click OK. Range was already there, so click OK, and then add on, then click enter. That's good. Then we are now ready to analyze our corridor for the computation of cut and fill. So on the prospector tab, we have here the compute materials. Just click this one. So it automatically select our alignment because that is the only one alignment that we have also with our sample lines. So just click OK, then click earthworks, existing ground, click here the EG surface, and then the datum should be the corridor. The volume calculation method, so you can choose average end area, presmoidal, or composite volume. This time I choose average end area. Okay, so click OK, and then just wait for a while. Okay, so we'll tabulate your volume, table type, table style is the cut and fill, table layer, select alignment, that is round 1, sample lines. Okay, material list. Excuse me. Then this is the arrangement of your tables. Maximum rows per table is 20. Then maximum tables per stack, we have 3. Okay. Offset meaning the distance between the tables across or down. Relatively mode, dynamic. Okay, we choose dynamic because we are going to balance it later on when there's a big difference of the cut and fill. That should be balanced, more or less. They have the same volume. Then we are ready now. We click OK. So we will click anywhere we want to place our table. Okay, so we have here our volume 3 stack. Oh, okay, so what's the total? So table 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26 tables, and there are lots of range because we choose 10 meters. So let's see the stationing. It is really by 10 meters, and oh my gosh, double because I clicked add. Anyway, this is the volume computation. Our fill or cut, what's this? Our cut volume is 262,000 while our fill is 37,000. So there's a big difference. Graphically, we can change that. So this is, oh, here it is. This is so big. That's why. So we can graphically edit that so that our volume could be balanced. So we'll just wait while our drawing is updating its. Okay, you can see here the cut was lessened. So let's try to see the total volume. We have here 30,000 and 38,000. Okay, let's reduce also the fill here. We can reduce the fill. Let's try to do this 8. Okay. I'm already. 24,000. Okay, 24,900. We can still reduce the cut here. We can bring this out. $33. Take some time to update. Okay, never mind this one. I'll just ignore this one. We'll see. Oh, it's 18. So we'll try to reduce again the fill. Can we still reduce that one? Yes. Okay. Mm-hmm. 13,000. It means this will become 21 again. One. Okay. Let's try to reduce more. Maybe here. Move this one a little bit. Almost 13 and then almost 15, so there's a difference of 2,000. Maybe Okay. So I'm ignoring this because this is at the station 0.01, so this is negligible. Okay. Let's try to see 12,007, and this is 14, 13, so 1.5 almost. We can still we have here we can edit this one. Let's try to remove this one. Okay. It's almost to 1,000. I'll further reduce the cut. Where should I go? Here, maybe. So I'll post this. Okay. Let's see. 991, that is 8 to 12. So 88, or say 89. We have only a difference of 89 cubic meter. Maybe that could be now. So in this area, you can see these are the fill area. Fill. Makikita natin dito. Yun. mas mataas yung kalsada natin sa natural ground. So we are approaching on an area where there is a significant cut. Here, dito sa right side. Kita nyo yan, sloping up. Dito sa left, something na medyo may tabon ng konti, bagyan. So dito banda makikita yan talaga, makikita mo yung napakalaking cut. Okay. Yan o, may sloping siyang pataas. Kaya ako ginawa kanina doon sa profile na masyadong malaki para ma-visualize natin dito. Ma-visualize natin yung cut, ma-visualize natin yung fill. Pero in actual, as I've said in earlier videos, na we should position our design profile as close as to the natural ground to minimize cut and fill, because there is a large cost on cut and fill. Okay, let's reverse it. See your design, it looks good. Papansin nyo dito sa gilid, pitch, makikita sa yung cursor sa left side, makikita mo very visible yung ditch, because this is a cut portion. Pagdating dun sa fill, wala kang makikitang ditch. Dito sa right side, very visible yung ditch. Okay, this is the end of the cut, and then papasok na doon sa right side is fill. Medyo may bahagyang cut dito sa left side, so makikita mo dito sa right, it really a fill. Okay, let's close this one.